Hey everybody, Dave here. Today, I am going to be doing more C# practice. Last time, I did Pascal's triangle on exercism.org. That involved just enumerables. Turns out I did it almost perfectly right from the start, even though I fully expected issues. And I actually learned a really important point about IEnumerables and yield return and stuff, that you don't actually have to do that all the time. This time, I'm going to be doing prime factors on exercism.org. And the instructions say, compute the prime factors of a given natural number. A prime number is only divisible by itself and 1. Note that 1 is not a prime number. So as an example, getting the prime factors of 60, you divide it by 2 and you get 30, then you divide 30 by 2 and you get 15. But when you divide 15 by 2, it doesn't go cleanly. You can't get 7.5. We're dealing with natural numbers, which I guess is like positive integers or something. Anyways, then you go to dividing by 3. So can you divide 15 by 3? Yes, you can. Then you get 5. Now, can you divide 5 by 3? No, you can't. Can you divide 5 by 4? No, you can't. Can you divide 5 by 5? Yes, you can. You get 1. And once you're left with just 1, now all of those results that you got, like each time that you successfully divided by 2 or 3 or whatever, those are part of your prime factors. One thing that threw me off is that 4 is not a prime number, and so how could it be a prime factor? But I think that it's just simplifying the logic for us, so we don't actually have to do only prime numbers for our sequence of dividing by 2, then 3, then 5. It's just letting us divide by 4 if we want to, even though that's never going to turn out to be one of our results. And so let's go ahead and do this. I think this is not going to be too hard. So let's see if I'm right about this. I like to predict in advance, how hard is this going to be? It says it's supposed to be medium difficulty, but I don't believe it. So let's get into it and try it. I'm going to delete this throw new not implemented exception line. I think what I would tend to do is something like a for loop, but I think I actually want to do a while loop for this. And what we're looking for is the number to equal 1, and that will get us out of the while loop. So while number is greater than 1, and then we'll do a bunch of stuff. And over that time, we're going to actually, that means we need to set this into a local variable. Let's do num equals number. I need to set that to be an int, in that with a semicolon. And then what we'll do is while num is greater than 1, so it will start as 60 or whatever. I guess we could go ahead and throw in some validations here. If number, I'm going to put in a validation for if number is less than 2, throw new argument exception. But I suspect it's possible that you're allowed to pass in the number 1, and your factor return should actually just be like an array that just contains a 1 in it. So maybe that's fair, and I'll have to come back and change that. And the other thing I just noticed is that I just set a long number into an integer num. So we need to set this to be long as well. And I'll need to keep correcting myself if I type integer. So I don't know if we need the divisor to be a long, but I'll just do it. Divisor equals, and we're going to start with 2 because we need to increment it from 2 to 3 to 4 to whatever else to determine the prime factors. While we're going along, I will need to add numbers to an array. So we'll just do a list of type long. Oh, now that I just realized that, I didn't know if divisor needed to be a long or not, but that's actually what's going to go into here. So it really should be a long. And then we're going to do list of long. We'll call this output equals new list long. And then at the very end, we are just going to return output, which is this is a list, so it needs to be converted to an array. To array. Now we need to add to the output at some point, output.add, and we'll be adding our divisor. We need to do some division. So let's do int result equals num divided by divisor. So long is just an integer, right? Which means that when you do the division, it has the same, it probably works the same as an integer does, like an int, because it can't have decimals. So if you do a division, then you need to check to see the modulo result. So like, I keep doing int. Long results, long remainder. So remainder is probably unnecessary to be long, but we'll just do it just in case. And we want to go num modulo divisor. And actually, I don't really need to set that into a variable. I can just do an if statement. If num modulo divisor is greater than 0, then we want to take divisor and increment it. We also want to add the current divisor to our output. No. So I think we move this down here and we increment. We might have an else just in case here. This is actually confusing me, so I'm going to move this back up here so that I can make my if statement less complicated. Long remainder. If remainder is greater than 0, then we want to increment the divisor because it means that we're now done with dividing by that number. If it is not like that, then we want to go ahead and add the divisor to our output list. And we also want to do something else. We want to update num equals results. Because we've done the division, we've basically decreased our number, and then we want to go ahead and update our copy of that number that we're tracking to eventually get to 1. And eventually, right, like, so if we got to here and then num is now 1, then we'll exit the loop and we'll have our answer. This might be it. So now I'm going to take another minute before I submit this to just make sure that I've followed the instructions and that I'm not missing any logic. Okay, let's see if we got it right. Oh no. Okay, see, this isn't fair. The last exercise set me up for failure because they had already imported the namespace. Using system.collections.generic. $11 tests passed, 1 failed. If there's no fail, what is this? Value does not fall in the expected range. Okay, see, this was like, I don't know what 1L is though. L is just an indicator for long. Okay, wow. So that's just like if it gives 1. So that's exactly what we were expecting up here. And like I said, I just don't ever know how to predict, is it supposed to throw an exception or not? I should just start returning an empty result whenever I suspect that I'm going to have it wrong. So I think I just need to do return, I don't know, new long like this. Array creation must have array size or array initializer. Okay, that's fine actually. I can do this. I know that there's probably a correct way to format this line. I just don't really care. So we're going to do return output.toArray. This will be an empty array. And then that should work. Yep. We solved the exercise. So let's just go make sure that we solved it using the correct concepts, integral numbers, and while loops. So that's actually cool. I wasn't sure how I wanted to solve it, what kind of loop I wanted to use, and this makes me feel good to know that I actually chose a while loop correctly. I legitimately was not expecting it to say while loops here. I had no idea. I didn't check that in advance or anything. So integral numbers and while loops. Okay, well, you know, I think that we did pretty good. And even though we messed up on the one piece, I need to start checking namespace imports. And then I also need to start doing my validations differently, where I normally will default to doing argument exception, but maybe I'll just start defaulting to returning an empty value if that's even conceivable. To me, it seems like 1 is an invalid input. Like, oh no, it is actually valid to try to get the prime factors of 1. It's just that there are no prime factors of 1. And so you're supposed to return an empty list. Okay, I guess that's fair. Maybe I could have seen that coming. So I'm going to try thinking hard about those two things next time and try to get it right. Thanks so much for watching, and I will see you in the next video.